So, hey everyone, this is the Sig-Auth meeting for May 24th, 2023. Let's see, I think we have a relatively light agenda today. So let's get started. Okay, so first announcement. So I think I've spoken with you about this, Jordan. So in 128, I was going to mark KMS v1 beta 1 as deprecated. And then once v2 goes GA, which is nominally supposed to be 129, there will be a feature gate that is off by default that you must enable in order to use the v1 functionality. So you would be nagged when there is a GA replacement to go do the work to replace your stuff.
I might have misunderstood. Does that say 128 we would deprecate and nag, but it wouldn't be GA to 129? That sounds okay because it's beta, but I want to be sure it's beta.
So Jordan convinced me not to nag, so we will deprecate in 128 and have it in release notes in 128. And then in 129, like let's say in 128 we add the feature gate, it would be enabled by default in 128, but in 129 it will be longer enabled by default.
Okay, I just want to make sure I understand when the nag is happening. Your intent is to nag not when there's a beta replacement, but when it's a GA replacement.
Yeah, but I want to tell people now there are no fixes coming. There's no improvements coming. Stop using this, please.
I don't know for sure that I agree with no fixes, but no new features I definitely agree with.
Yeah,
that sounds reasonable.
I mean, I don't know what we would fix at this point.
If we found a vulnerability in KMS v1, we would try to fix the vulnerability, but we're not going to like try to address the scale issues or the things that KMS v2 was intended to address.
Yeah, right. That makes sense.
And just to be crystal clear, I know you and I agree on this, Mo. Like we say deprecated, we are not ever intending to drop the ability to read KMS v1 encrypted data out of etcd. We probably ever. So people get really anxious when they hear the word deprecated and they're like, oh, is it going to be deleted? And no, but you should stop using it and move to v2 because it's better in every way.
Yeah, I think.
Are you sure about never? Like
no, I'm not sure about never, but a lot of things would have to change, like automatic storage migration, I think.
I think that's the one big one that I see.
Yeah. So when we're saying deprecated, this is not so we can start a clock and like drop KMS v1 read support in 3 releases. That's not why we're marking it deprecated.
Yeah, so I think sort of the maximum concrete plan I have is if v2 was GA, maybe 3 releases, maybe even more than that, we would drop write support for v1. So you could deprecate, you can move off of it, but you're not supposed to use it for writes anymore at that point. But that's like the earliest I feel comfortable. So like a year after v2 GA.
Yeah, but that's a separate conversation. This is just to tell people, like, correctly label the KMS v1 feature as like it's not going to get better.
Yeah. So not if the feature is not going away, but we'll only have critical bug fixes going forward. Basically.
Yeah, critical's in the eye of the beholder. Like best ever security fixes. I don't know.
Security bug fixes in the future. Yeah, that one is easy. Does it leak the crypto keys somehow? Then sure, we will fix that. And if it somehow does that and we haven't noticed yet, almost certainly v2 probably is impacted too. So that'll suck. Okay. Okay, so I don't hear any issue though on the relative semantics here. Okay, I can, I guess, move to the next one, which is a little demo. So I know I don't see any EKS folks on the call, but I know that they were interested in external signing of service account tokens. And one of the things I had asked about was to have support for certificate-based signing of service account tokens for that feature, basically. So that way, if you wanted to have external private key material that isn't directly accessible, you could still like provision like short-lived certificates like into the cluster that you want. So that way, in the same way that like KMS v2 fixes most of the performance issues of KMS v1 by moving the external server out of the main loop of the every call, basically. That's what you could do with certificate-based signing. So I implemented that, and I was going to show a little demo of it just for kind of fun. But obviously, I did not implement this with an external signer. I implemented it with an internal, like the internal code. So let me stop sharing this terminal, and I will share my other terminal. One moment as I remember how to share screens. Good grief, where's the button? Here it is. I will say Teams has broken my brain. I can no longer remember which button does what in all the different chat apps I have to use now. Okay, so I just have a locally run, this is almost certainly way too tiny. I have a locally running terminal that has a local cluster up running from that branch. And so let's see. So if I show this, so if you guys remember, OpenID has a JOX endpoint for the API server. This is the regular key, the one that we have today. This is the key that is based off of a CA. So, you know, it's got some key ID, but you can also see that it has an X5C header. And so this is the root CA, right? So obviously this is the public key information of that root CA, right? And then let's go, let's see, what should I do next? So if we were to create a token, we can, let's do auth first. So if I do who am I, but with a token for the default service account, we can see this nice little warning that I added to the code base so I could actually see that my stuff was working, because Jordan's really happy because it's a warning, because that makes him happy. It's one of the easiest ways to demo something now, Jordan, is to log it as a warning so you can see it in your terminal. It's great. I love it. Also, it worked the very first time, so I was super skeptical that it actually was doing anything. So I had to add this warning just to prove to myself it was doing anything. But so like if we look at the token, so if we look at the token and we just grab the header and decode it, we can actually see that it has an X5C certificate in there. But if you look at this key ID or this key ID, it does not match this key ID, right? Because this certificate, this token is signed by a certificate that's not in here. It's a certificate that is chained up to this root CA. So I can show that. So if I was to show this real quick. So this is the root CA that's from the JOX endpoint. And we can kind of see, you know, its parameters. And then if we look at the one that I get from service account token, it is a different cert that has, you know, it's not a CA, but it does have client auth on it. Whereas like, I don't know if OpenSSL shows it here. I don't know if it shows CA there. One of the things I ended up doing, because after sort of reading stuff online about this flow, like the biggest mistake I saw that people tend to make is they put a root CA into their trust that doesn't semantically make sense for tokens. So for example, they'll put like DigiCert or something in there. So basically anybody's anything can be kind of used, because anyone can ask DigiCert to give them a cert. And obviously I know if there was CA-based support, someone would try to use their company root CA, because that's what people do. But I don't think the intent there would be that I want my company's root, any certificate signed by my company's root CA to be also able to sign tokens that are used within my Kubernetes environment. That doesn't make sense. So to try to safeguard that, I basically made the code require that the DNS name on the leaf certificate basically match the issuer hash that's configured on the cluster. I don't know if that makes sense. It's something. Let's see. Did I want to show? Is there any questions at this exact point before I go to like the code to show people what it actually does at code?
I had one question about the key ID stuff, right? So if the key ID does not match, like if the array, there are multiple elements in the array, like typically they use the key ID to figure out which one to do. But with this, would they have to go through the array and try out all the different ones to see which one works?
Yeah, that is fair. I guess if you were so for the API server, it doesn't matter because it only trusts like one root CA. Like, sorry, not one. It only trusts a roots, a bundle of a set of roots, right? So it doesn't matter how it chains up to any one of them or more than one of them. It just has to chain up to one of them, right? So right now the logic is very kind of simplistic where it just says, okay, do I see a token? Did it fail the normal token verification for service account tokens? Do I have the ability to do root CA verification, and does that token have an X5C header? If it does, then it'll try to basically root up to that, the roots that are trusted. And if that works, then it'll take the public key from the certificate and use it to verify the actual token. So I think the reason you're asking that question, Anish, is the fact that like if you were an external provider and you were trying to verify these, it might be more difficult because you might be verifying many different ones. Like you might have many different roots that you trust as separated trust domains and then have meaning across them. So I think we'd have to think more carefully about how we do that. Obviously, one way would be to make it so that the key ID that's in the token matches this one. You could totally just do that. I guess that would totally be fine. It's not really used by the API server, so I think we could make that.
Are there expectations in the spec, like the tokens that come back, that the key ID will be represented in the shop key set? Or is that different for X5C stuff? I'm just not familiar with X5C validation of jobs.
I'm not 100% sure how that plays in with X5C. I'd have to look at it more closely. So I can take that as an action item to kind of.
Yeah, I feel like some of the client libraries would trigger refreshing their view of the key set if they saw a token that had a key ID that wasn't in the last fetched one. But I don't know if that's like an on failure fallback, or if that's hopefully it's not like I saw a token with a random key ID, let me go fetch, because that would be a denial of service vector. But
yeah,
I don't know. It's worth checking.
Yeah, so that's good feedback. Yeah, and I think it probably makes sense to make this and this match, mostly because the API server doesn't use this at all for its verification. So it could just be for external actors to figure out which root CA they're supposed to chain up to. Let's see, was there anything else I wanted to show on that one? I think I'll stop the terminal stuff and go back to the code real quick. All right, where did? Okay, so on the code, it's actually like a relatively small change. So if we look at, this is like the main authentication logic for service account tokens. And basically, if regular key verification fails, it will basically check, can I do TLS-based or certificate-based verification? And does the token that's being sent to me have an X5C header on it? If so, what it's going to do is it will take the verification options that it has. So that includes the root CAs that it trusts. and then it will try to chain those up with the certificates that are on the X5C header. And if that works, it will take the leaf certificate, get its public key, and then use that to actually verify the token itself. So that's basically how it ends up chaining up, right? So you trust the leaf because you trust the root, and then you can use the leaf's public key to verify the signature of the job itself. So basically it's like dynamic keys, effectively. It's kind of what it ends up being.
When you say the leaf, do you mean the leaf certificate?
Yeah. So the leaf that was used in the chain.
Okay.
Okay, questions?
Can we tie this all back to the AWS EKS thing? Like, what properties of this make you see it as a viable alternative to their?
Oh, it's not an alternative. It's meant to be like a co-requisite, basically, is that if we support that flow, the like EKS is sort of happy to make it so that every time a service account token is signed, you have to make a remote API call off the API server and go off to wherever to get stuff signed. That's not necessarily tractable in the environments I'm responsible for. So I wanted an approach that could sort of mimic what we did for KMS, which is keep everything within the API server as much as possible and only in the background have the external remote call. So the way I would see this happening is the plugin, this external, like I don't know, a gRPC plugin could sit there and, every minute or whatever, hour, whatever, get a certificate issued by some root CA that's trusted, and then use it for signing.
I guess, how does it how is this different than having a key per server and publishing that via the Jukes URI without the X5C?
A key per server.
I guess, like, imagine this with without X5C, where you just publish the
Oh, I see.
keys. Yeah. What?
So I think the difference there is the certificates are inherently lifetime scoped, right? So like you can keep them short-lived and they don't have any meaning outside of that tiny lifetime, whereas a public-private key pair is just forever until you decide to rip it out of the endpoint.
So in a path validation for X5C, we're not going to validate. Like, I mean, this
function just does cert.verify. It's like basically exactly what you do in regular TLS stuff.
But then the keys, you're not like.
Yeah, so it does. You have to keep it at least 10 minutes because that's the minimum length that we want tokens to be valid for.
But if, like, what is are we trying to reduce exfiltration risk of a key? Like, and these keys live forever, so I can just still pull one out and use it in perpetuity to sign service account keys. If they're not like.
I think what it would end up giving you is just like pretty dramatic constant rotation effectively.
Yeah, but with like, if I publish all the keys that I think are valid, I can at least remove them. Here, if we're not doing any like validity duration validation in the path validation, then a key that is used and potentially exfiltrated can be used in perpetuity, right?
Did I say something that made it sound like we would not be doing time-based validation?
Okay, well then if they're valid for an hour, then the tokens can only be valid for an hour. And then we could just swap, like, I guess we could just keep swapping out the keys that in the Jukes URI every hour or something.
Right. So that's one of the nicer things is you don't have to make external actors check all the time, right? The root CA stays stable and is ideally somewhere deep within your vault. I guess.
Okay. So it would reduce the amount of fetches to the Jukes URI needed. And the trade-off is like larger tokens.
I mean,
And more complicated validation. Like I don't actually know how good the support for X5C Jukes is across like JOT verifying.
yeah, so I think the way that would end up having to work is you in your plugin would decide when you want to use this. So like that sort of is up to you, right? Like you don't have to use it all the time, or you don't have to use it at all. There's no hard requirement to use it. I'm more talking about having an option and then letting whoever is issuing the tokens issue them that way. And if they're not valid to the other entity, well, it's going to fail very obviously.
Yeah, but by like, I'm trying to think if this changes or expands what someone using a Cube API server tokens and how they're verifying them. Like today, we don't support this. So nobody verifying tokens against Cube API server today would necessarily know if their X5C support was broken. As soon as Cube API server supports, even if it's optional, like supports an integration that can produce tokens like this, produce jukes like this. Now, every client that runs against Cube API server and verifies tokens has to at least consider the possibility of tokens like this. If they're going to like say we interoperate with random Cube API server XYZ. So
Right.
It would be good to know like maybe a survey of the not just the Go ones, but sort of the top 1, 2, 3. Like if I was going to validate JOTs in random language, whatever, what library or libraries would I likely be using, and do those actually support X5C? Like knowing where this level of support is in the ecosystem would be helpful.
When you guys did the OpenID stuff for Cube, what did you validate in that process for consuming of tokens? I'm curious.
I think, what did we do? I think we wrote it up.
Yeah, I mean, if you wrote it up, that would be good. Then I could try to poke at it and see. Mike, you want to go?
Definitely, I recall it, AWS explicitly and Vault OIDC credential backend.
Looks like said the feature has been confirmed compatible with several independent relying parties. Basically the federation solutions for the cloud providers and looking at popular OIDC libraries. So we could dig into maybe the graduating PR to see what got pointed at, but we did similar sort of due diligence. There, I think the tokens we were generating at that point were like bog standard tokens. It was really just the discovery, like hitting that discovery URL and being happy with the discovery contents that we're serving. Yeah. So that, in my mind, that's a smaller surface area than like a new type of token signature that's pretty esoteric.
That esoteric. I mean, come on, like if it was that esoteric, I don't think I could get the whole thing working in what, like 250 lines. Can't be that esoteric.
That just means that the library we're using had support for it, which is awesome. I don't have any sense for how common it is.
Yeah, that's fair. Okay, so I will. All right, so I need to investigate outcome. X5 support. Do that. Any other thoughts or comments? I think I would generally agree with the sentiment that we wouldn't do this unless there was something else to tie it to, right? Like I wouldn't like, so I ended up adding like 2 flags to the API server to make this work. One was well, what are the root CAs that you trust? And the other one is when you generate a token, or when you sign a token, what X5C stuff do I need to attach to make it so that on the way back in that it'll verify correctly? So that's just, like, what is the public cert for your, right? Because the private key that you're given for signing is just a private key. It's not a certificate. So it doesn't know that piece. So I did that, and that's fine. But I don't think we would do that unless there was compelling reason, effectively, or some variation of that.
Yeah, that sounds good. Let's just be super crisp on the cost benefit trade-off and like the cap.
Sounds good. Oh, let's see. I know we have KMS stuff again. Anish, is Heba on the call? Let's see.
Nah, I'm pinging her.
Okay. All right. Cool. Well, you can ping her, and I guess we can talk about KMS v2 crypto. So Mike, you and I spoke about this at some length, and I took most of what you wrote up and then added more comments based on my last conversation with Jordan. And I just wanted to see if we were in consensus enough, or at least for me to go try to implement all this and get it ready for 128.
Yeah, I think the alternative that is not here is the AES GCM SIV implementation in Tink, as like which seems to be the only potentially viable implementation of AES GCM SIV in Go. So
yeah, so I think the biggest concern I had with like the Tink one was like the open issue to add support into standard library has like a PR or a change attached to it that is like mostly assembly code. There's a bunch of assembly in here. So then I was confused / concerned about how the Tink library was implemented in just Go.
I guess the like polyval hash is just a Go implementation. There's a no ASM implementation here.
Well, yeah, I mean, there's always a OSM one just to make it fall back if you don't have the right platform. But I more mean like, we're probably going to run this on AMD 64. Right?
I guess what are you concerned about performance?
And any random timing something and others that show up. And I may be at a high level of like, well, it's not in the standard library. Are we sure? I mean, you could argue Superbox is not in the standard library, so we maybe have already crossed that chasm. So for folks that are not familiar, it's nonce misuse resistant. So if you have a nonce collision with AES GCM Civ, all that happens is you lose the ciphertext of like the current object effectively. You don't catastrophically disclose every single thing that you have previously encrypted with that stuff. So it like basically limits your screw up to basically the current thing that you were playing with. But you pay a performance cost for it. I forget the percentage that was in the RFC.
When you say lose, you mean disclose?
Yes.
Right. Okay.
So instead of with regular AES GCM, with like one collision, if I remember correctly, you like immediately disclose the plain text of the things that collided plus the authenticating key. And I think if you have more than like 3 or 4, then you just catastrophically lose the actual encryption key that you had. Something along those lines.
I don't think that is right. With AES GCM, you lose authenticity. So you lose the authenticated encryption, but the hash can be, the like chained hash can be attacked, and then you can XOR 2 ciphertexts with the same key, same nonce, to get an XORed value of the plain text. But like the SIV, I think it's the ciphertext, or the plain text, and the nonce and the key are all combined to create a synthetic IV, which would be different for different plain texts, and that prevents that results in the collision resistance with something called polyval. But I think the only problem with repeated, yeah, I'm not sure that you lose a single ciphertext with a reused nonce with AES GCM SIV. I would double check that, but
even if you ignore that, I know that if you have a few nonce collisions, you can basically do some polynomial math to retrieve the actual encryption key.
Mm.
It's one of like the exponents and like the shared polynomials across things. Like that one I did dig into pretty deeply. So that's the real concern, right? Is we're using the same data encryption key effectively for the lifetime of the process. So if there were a handful of collisions, then it's kind of just hosed. Basically everything you encrypted with that is kind of gone.
And the collisions, because we're using an incrementing integer for the nonces, the collisions were mostly around like VM restore scenarios where
I don't think we have a
write and then restored, or something happened and memory went back to a checkpoint and like replayed the same iterations.
And once it replays them, it'll have many collisions basically as far as when it went back, right? It's because it's just a
yep.
But the other thing is, there's no great implementation in Go, and I do not know if there is a FIPS implementation in any of the standard FIPS OpenSSL distributions, which are two downsides.
That does seem like a big downside.
Sorry, Mike, can you clarify which thing doesn't have a FIPS implementation?
I don't think ASGCM SIV. I couldn't find a FIPS implementation.
I'm unaware of that myself, but I hadn't thought of that. That is true. That is in itself problematic. FIPS can't seem to get away from it.
It's relatively new.
That was going to be my next question. Like how like battle tested is this, and how confident are we that we'd be happy with this as the foundation for KMS v2, like forever?
2019 was the standardization.
Yeah, I mean, not young.
Which is why there's no FIPS, because it takes 7 years to get a module.
Oh, that makes sense. So we're almost there. 2026, y'all. It'll be there in 2026.
And you said the standard library implementation isn't merged yet.
Yeah.
Yeah.
So I don't know if it is going to be, right. I don't know if like Filippo or anyone else who cares about this stuff actually wants to. It's like, what is it? Yeah, it's just a proposal, I guess, right now.
There's a Tink implementation, and the reviewers legit, I don't know how widely used it's been though. It's a pure Go. I guess we can move on to the second option.
What was the second option?
By a second, you mean what's written here, Mike?
Yeah.
Okay. Yeah. So the first option, and I'll try to write some of the details down in a bit for it, is basically what we just talked about, which is the SIV implementation. So that way, if we screw up the nonce, well, it's not a big deal, or it's less of a big deal, and we can kind of stop worrying about it. The second option is basically a scheme to basically extend the nonce that AES-GCM is using. So the nonce size of AES-GCM is just 12 bytes, and there's no way to increase that, because if you try to give it more bytes, it just hashes them down to 12 bytes. So don't waste your time. So that means that you do need to do some kind of key rotation because the chance of collisions goes up if you do too many. So KMS v1 got around this whole problem by just never reusing a key ever. Created the problem of horrendous startup times and performance costs because you were constantly hitting the remote KMS to decrypt or encrypt the DEX you were using. So this scheme, which is roughly analogous to what we discussed a while back with the diagrams and stuff I had, was we would stop calling the thing that we send to the plugin the deck. We would probably start calling it the seed, which would be a set of 32 random bytes. And then we would use 16 bytes of a nonce with HKDF expand and SHA-256 to basically generate a random key per write. So I don't know if the math works out exactly as like an additive to the nonce, like if you could pretend it was a 28 byte nonce total. But just as an example, Secret Box uses a 24 byte nonce, and basically it considers that good enough for just having random nonces. And then we would end up storing so today we already stored the nonce, the 12 byte nonce alongside the encrypted deck and ciphertext. We would now just store more nonce data, so that way we knew how to regenerate the deck that was actually used. And then to make reads not take a performance hit from HKDF, we would have some kind of cache, probably unbounded size, but then we would limit the growth of the cache by giving each entry some TTL, and probably will make the key into the cache the etcd path of the object, which we already have. And that would prevent like frequent writes to the same object from polluting the cache too much. And then if you were just making lots of new objects, then the TTL would prevent unbounded growth. That's kind of how we would keep the cache from going too big. But the cache would basically just say, oh, I see that you have this nonce as input. I know what the deck that goes with that is, so I'm just going to use that. You don't have to go through the full math, basically, of HKDF. So this prevents the issue of a nonce collision because you never really reuse the same key. So if your nonces collide, it's kind of whatever. Yeah. Jordan, you look very unhappy.
That's my confused face. I just can't. I don't have that in my head, so it's hard for me to reason about. I would probably lean really hard on folks like Mike and other folks who either can reason about like that chain of construction for the nonce, or have like crypto review teams they can ask about that. I just don't. I can't. I don't understand what each of those like lengths and chaining those steps together. I don't know what the properties of that ends up being.
Yeah, we can make sure that the smart people double check that that math.
Mike, did you get any other feedback from the crypto folks at Google?
Not yet.
Okay.
Still waiting on it. I'll poke them more actively.
Picturing a bunch of people like around a whiteboard in the college lecture room trying to determine whether this works. Beautiful mind style.
Or like the conspiracy theory guy with like pins and red yarn.
Yep.
So yeah, like assuming people who know what they're talking about look at this and say this like cryptographically is solid, knowing what the performance overhead is was the only thing I really had an opinion on. And I think if we key the cache off of the etcd key, so we retain at most one decrypting key per actual etcd entry, then that insulates us against cases where someone's doing a ton of writes of the same objects. And did you have the overhead? I think it'd be helpful to throw the overhead per cache entry in here, just so we can kind of reason about what the memory use would be for various amounts of etcd data or etcd object counts.
Yeah. What are you concerned about? Memory usage? Overhead?
For the cache, I'm concerned about memory usage overhead because like someone spamming updates to the same object will actually get compacted out of etcd, but unless we limit the cache to roughly match like the number of objects in etcd, you could do a lot of writes in like an hour. And so like thinking about what's our max QPS, what's a ballpark like max writes per second, how much overhead is there per key?
Yeah, so I can paste these numbers into the doc, but like last numbers I collected was that with on a write, so where you can't have a cache or anything, or at least not easily, you go from 6 allocations for just regular AES GCM to 32 allocations. So it's not free by any means. And then you go from like 42,000 nanoseconds to 96,000 nanoseconds. So it's like twice as slow, but I mean, we're still talking 50,000 nanoseconds, which I forget was 59%.
We also have a number of other egregious performance issues, like not issues, I guess, because nobody has noticed them, but we are so lax in other places that I feel like examining this in isolation is kind of makes me scratch my head.
The performance on write, I am far less concerned about. The performance on read, if you're going to do a global list and we're paying this overhead on every read of every object, that's way more concerning, which makes me think we need some sort of cache. And so then my main goal for the cache is to not let you the server. Just because you're doing a bunch of writes.
So we store encrypted data in the proto for KMSV2, which means every time we deserialize a record, we have to copy encrypted data from the object rather than if we had stored it as like the object as a prefix and then the data, we would not have that extra copy. The other thing that we do, which is not great for allocations, is for every runtime unknown in protobuf encoding, whenever we serialize that, we do a full copy of the proto message.
So as a reminder, Mike, this code path doesn't go through that specifically.
Why does this code path, the first part?
It doesn't go through the standard runtime decoder stuff that we have.
It does eventually. It does when it goes to
keyboard. For the actual object, yes.
Yeah, so like both of those are like full object copies. I think that if we want, maybe we should revisit putting the encrypted data in the proto message and storing the proto message as a prefix to the encrypted data. If we don't want to copy that every time we read, which was the behavior of V1.
I see what you mean, I think. Yeah, okay. So like if we were treating it as a raw bytes, we didn't have to put it in like a struct. And
yeah, when we deserialize on Marshall with proto, that data is going to get copied byte for byte into the proto object. And then we're gonna, I don't know what your implementation does, if it does in place unencryption or not, but then that has to get copied again from ciphertext to plain text. So we can reduce the number of those copies down to just reading it from etcd or whatever, and make back everything that we lose by doing this HKDF.
But then we lose all the nice structure and stuff that the proto gives us.
Yeah, I don't know. So if it is important to you, then there are like other places to look to get way more bang for your buck.
Yeah, so maybe it seems like there are two things to investigate there. One is to make sure that the benchmarks that we had that are saying here's the comparison between GCM and SAV, make sure those benchmarks or have a benchmark that captures more of the operation that we actually go through when we read the object from etcd, so that it would sort of show what Mike was talking about in proportion. Like, yes, in isolation, the GCM goes from 6 allocations to 32 allocations, but this is part of a bigger operation which involves 10,000 allocations. Like, that would be helpful to know for context, but I don't know what those numbers actually are.
Okay, so like benchmark like a complete like read and that's your right from etcd with real like cube secret data or something like that. Okay, that's fine. I can take that. That makes sense. So let's say that the benchmarks are fine and the performance is acceptable. So we're okay with this approach, barring our crypto friends telling us that we're doing crazy stuff, basically. I don't know what that beep was. Was that beep saying let's move to the next topic? Okay.
10 minutes to my next meeting.
I see. Heba, I see you on the call. Did you want to talk about your thing?
Hi, everyone. Nice to meet you all. Sorry to interrupt the Sig-Auth meeting. It's just related to, I think you have a repo called Sig-Auth tools. This repo just, like to have some GitHub actions to run to monitor the dashboard for the Sig-Auth and, like other stuff like that. And we would like to like make it more general. So instead of, we wanted to reuse it. So instead of just duplicate or replicate the repo for Sig scheduling, we would like to just see if this is okay to rename the repo name and make every Sig can just contribute one file, which is the GitHub action, instead of just, like own and maintain a separate repo for that. Because I know we have a problem across the organization, Kubernetes organization, that we cannot create GitHub actions in Kubernetes repo. So I believe this will be like a good solution for now until we figure this out. So just wanted to make sure, what do you think about that?
So for context, the Sig-Auth tools repo has a GitHub action that looks across the entire Kubernetes org at all the issues, finds the ones that have the Sig-Auth label, and then adds them to the GitHub project board for Sig-Auth. So that way we don't have to go find them ourselves. And when people make random issues in like the kubectl repo, we actually notice instead of ignoring it for months or years at a time. And the reason that that's a GitHub action is even though we use the latest and greatest GitHub features in our project board, you can only tell a GitHub project board to automatically add issues from one repo. You can't tell it, I want everything from an org. I have asked the GitHub projects board PM about this before, by the way, so it's not that they're not aware. But that's what it exists to do for context.
And this is great. And actually, I feel like, like that this will benefit like everything, because, like having everything in just one dashboard, it's great. We had the same issue in release team, and we had to go through like creating a new job, with special script to run it in pro, and, like having it updated every release cycle. But I believe we don't need that here. It's more easier, like if we just have a GitHub action, scrap the whole org and just put the issues and PRs in the dashboard.
So a couple thoughts. Does ContribX have any repo that has like generic tools and helpful things for SIGs to use?
Not yet, but we have been told that we can contribute this back to contribute X once we have it like general.
Okay.
Yeah.
Is the intent for this repo to evolve to be able to have more than one GitHub action? Like I think today is, if I'm reading it correctly, it's like one action at the root.
Yep.
So would we want to? I'm trying to understand if the goal is to have like a repo for actions, and this would be like the first action, in which case it might make more sense to start a repo for actions and like copy the code in its current state into that repo rather than trying to like rename it and move it around. I don't know.
Yeah. This is my suggestion, actually. It's just to have a repo with multiple actions. For now, we have this repo with just one action for now, and a code that, like script the organization. So yeah, but it would be great if this is a good idea to generalize it because we need it from time to time.
The second thought I had, the nice thing about this repo is we have exactly one consumer, and it's auth folks. And so the only people touching this are auth folks. And if we break something, then it only affects our project board, and like we're on the hook for noticing and fixing it. As soon as you have one action being used by a bunch of SIGs, now it's like you have people contributing to that action and it impacting edge cases in other SIGs. And so you have a lot more requirements around like, how do you test this thing? How do you notice that you broke everybody? Like, so I like the idea of a generic thing. I don't know what the plot for it is.
No testing, dude. It's a Ghost script in like.
Well, but that's the thing. Like it runs, and if it breaks, it screws up our project board, and we notice, and we have to go fix it by hand. Like as soon as it's a thing that other people can contribute to, now I don't know if everyone who's contributing to a shared thing even knows it's being used against the auth board and is able or willing to go fix up the auth board by hand if it breaks.
I get your point. You have a total valid point. But again, I just like trying to reduce the number of repos that we are creating just for the same thing. It's like I will just like fork the repo, rename it, and have to maintain it by myself. It's everything, the same code, the same everything. We can add like, this is what like this piece of code or this piece of script does 1, 2, 3, and like if you wanted to create a new thing, you can contribute a new one. But and everyone can create its own set of GitHub actions and separate folder under .github folder, and it's like maintained by the SEG leads or the SEG. It's like it will be per SEG.
A repo to have a structure like that, where with a folder per SIG, where like a natural home for code like that makes sense to me. I'm not sure that renaming this repo is the right way to get that, or if creating a single repo like that, and then having a folder per SIG and saying you can drop actions in here. And maybe if we had that, we would drop or move this action into there and turn down this repo. I don't know.
Okay. So your suggestion is to start a new repo, just like to host something like this, and you can move if this is okay. But for now, I will just create a new repo, right?
Maybe like a single repo that can be used by multiple SIGs to run GitHub or host GitHub actions makes sense to me. Instead of having to create one per action per SIG.
Okay.
I would lean on ContribX and test in for folks. I know you said you had done this as a Prow plugin before, and it was painful.
It's not, but it's a long process, and like we can do that, but I feel like this is the main thing for GitHub Action. It's like that, and I wanted to, like just revisit again that to open a door for, like GitHub Action in a secure way to just start to use it in the org, because it makes a lot of sense and it's easier, to be honest. But again, I've done this already in Pro, so if this is the right way, I'm totally fine.
The other sort of data point I wanted us to consider is, I think at least for right now, the reason that we have this action is just because of the missing feature in GitHub project automation. Presumably they'll eventually get to that and have it, and then we won't need this specific action anymore. However, do you have other things that you need to automate with actions that are like different from this one?
Right now, no. I just wanted to make sure maybe in the future we can have like more automation, like, like if you have this label, move it to, like need review, or, like need approval, stuff like that. It's like, like more organized dashboard. But what we have today, this is more than perfect. This is all what we need right now. But again, in the future, yes, we can, especially in SEGs, like we have a lot of work groups, and we might need it. I don't know. I don't have anything in my mind right now.
Okay. Yeah, I guess I don't know. I don't have a super strong opinion. I'm kind of happy with whatever. I'm basically happy that I got Anish to rewrite this from a Bash script into Go code, because to me, Bash makes my eyes bleed and Go makes me happy. So here we are. I've already succeeded in the goal I had.
Yeah, one more thing to, like to love Anish about, what he's doing. So yeah, I love this. Okay, so I will go ahead and I will propose this to contribute X, and hopefully it will be okay. Otherwise, yeah, I will just create my own repo for the sake of scheduling as well. Perfect.
Cool.
Yeah.
We are over time, so thank you everyone for your time, and I guess we'll see you all in 2 weeks.